Hi everyone, welcome back to the coding series. In today's video, we will be solving LeetCode problem number 560 subarray sum equals k. Let's understand the problem statement. Given an array of integers nums and an integer k, return the total number of subarrays whose sum is equals to k. A subarray is a contiguous non-empty sequence of elements within an array. Let's understand this with an example. Given array 1, 1, 1 and given sum is 2. Okay. Now let's see how many subarrays we can form. 1, 1, 1, 1, 1, and then 1, 1, 1, and 1. Let's check which and all subarray sum is equals to k. This subarray sum is equals to k. This subarray sum is also equals to k. You have to return total number of subarrays whose sum is equals to k. So here answer is 2. So in the second example, 1, 2, 3 and given sum is 3. Okay. This subarray sum is 3 and this subarray sum is 3. So here output is 2. How we can solve this? Let's start with brute. Okay. So given array, first you start traversing through array. Okay. Now you will append this value to the current element. Okay. Now you check whether this element is less than given sum or not. If it is less than, you will start adding other elements. Okay. And you check whether this is less than sum or not. If it is less than, you start adding other elements. And you go to the next iteration when this sum will be greater than k or given sum. Okay. So like that, for when you start I equals to 0 and you update current sum with this nums of I and you check whether this current sum is less than given sum or not. If it is less than, you start adding other elements. So you start iteration for j equals to I plus 1. Okay. So if you see like this, so for one element, we are checking for n minus 1 elements. Similarly, for n elements, it will be n into n minus 1. Okay. So that will be n square minus n. So here time complexity will be O of n square, because this will be O of n square. Okay. Now this is quite big, right? Now let's see. We have optimal solution as well. Let's see that. Okay. So before to that, let's understand prefix sum method. Okay. So this is the formula for that. Prefix sum of j minus prefix sum of I minus 1. Okay. Prefix sum of j means total elements till j position, total elements till I minus 1. Total elements means sum of elements. Sum of elements till j position minus sum of elements till I minus 1 position. Okay. Now let's see. For 1, 2, 2, 3, if you want to calculate 2, 3 positions sum, here that is 5, right? So using this formula, prefix sum of j. Okay, that means sum of elements till j, that is 6, minus sum of elements till I minus 1. Okay, that is I minus 1, this one. That means 1. 6 minus 1. Okay, that is 5. We have achieved that. Okay, so now using this formula, okay, so how we can solve our approach, okay, or how we can solve our problem. Sorry. Now here, if you think sum of I comma j as k, because you have to return total number of subarrays whose sum is equals to k. Okay. Now sum of I comma j is equals to k. If you take this here, so prefix sum of j, okay, minus prefix sum of I minus 1 is equals to k. Prefix sum means total elements or sum of elements till j position, that you can take as current sum, minus k is equals to prefix sum of I minus 1. Okay. Now, keeping this in mind, let's solve the given problem. Okay. Now, initialize one hash map to store all the current sums. That means prefix sum of every element. Okay. So if you take 1 comma 2 comma 3, initially current element will be sum. It will be 1. Okay. Now for 2, prefix sum will be 1, right? For 2, its prefix sum will be 1. Okay. Now let's take one hash map to store all our prefix sums. Okay. Now, but for first element, its prefix sum will be 0. So you have to start taking from 0, 1. Okay. You have to initialize one hash map with 0 and 1. Okay. Now let's see this problem. Let's consider nums as 2 comma 3 comma 5 comma minus 5. Okay. Now here current sum and given sum k is equals to 5. Okay. How many subarrays you can form? 2 3 5, 2 3 1 and 2 3 5 minus 5, because 10 minus 5, that is also 1, and just 5. So total 3 subarrays with sum k equal to 5. Okay. Now using this formula, let's see. Okay. Now current sum, initially it will be 2. Okay. Now check whether current sum minus k, 2 minus 5 minus 3, whether if this is present in our hash map, if this is present means then that subarray is having sum is equals to k, right? So here now you check whether minus 3 is present in our hash map. No, it is not present. If it is not present, you have to update this current sum every time into the hash map if this current sum is not present. Okay, here current sum is not present, so you have to initialize. Okay, because this current sum will be the prefix sum for this, right? So you have to update that. Now current sum will be, here current sum is 2 and you have to add 2 plus 3, that is 5. Okay, now check whether 5 minus 5, okay, 5 minus 5 is 0. Okay, now 5 minus 5 is 0. Okay, now you have to check whether 0 is present in the hash map. Yes, 0 is present in the hash map. So what you have to do? That means these two elements sum is equals to k. Okay, that means that subarray is forming sum is equals to k. So you have to update its value. Here for 0, its value is 1. So you have to keep a track of these counts every time. Okay, you have to update that. And then you have to, here current sum is 5. Okay, so you have to update that. You have to check whether that sum is present or not. If it is not, you have to update in the hash map. As I mentioned, this will be sum for this will be prefix sum for this one. Okay, now current sum is 5 plus 5, that will be 10. 10 minus 5, that is 5. Okay, here 5 is present. Okay, here 5 is present. That means here forming contiguous subarray with sum equal to k. Now you have to update that into count. Okay, for 5, what is the value? 1. So 1 plus 1, that will be 2 here. Now you have to update this current sum in our hash map because it is not present. Now current sum will be 10 minus 5. Okay, now because previously current sum is 10 plus, now current element is minus 5. So 10 minus 5. Now 5 minus 5, 0. 0 is present, right? 0 is present. So what you have to do? You have to add that in our count. 1 plus 1 plus 1, that is 3. And you have to check whether our current sum is present in the hash map. Yeah, it is present. You have to update that to 2. Okay. Now you have reached at the end of the array. What you have to do? You have to return the count. Here count is 3. Similarly, when we checked earlier, here how many contiguous subarrays you can form? 2, 3, 5, and then 2, 3, 5 minus 5, 5, and then only 5. So total 3. So with help of this also we got output as 3. Now let's code this. So initialize one hash map. Map of int with 0 is to 1. Because for the first element, its prefix sum will be 0. So for that you have to initialize this. Okay. Now count current sum. Initially it will be 0. You have to iterate over elements of nums, and then now you have to check. You have to add that to our current sum plus b, and check if that is present in our hash map, like current sum minus k. If it is present, then count is equals to count plus hash map of current sum minus k. And if it is present, now you have to update our current. You have to add current sum to our hash map. Map of current sum is equals to hash map of current sum plus 1. And then what you have to do? You have to return our count. First, let's submit this. Yeah, all test cases are passed. Here, we have solved this in the O of n time complexity because we are iterating over n elements in an array. Okay, so it will be O of n, And for the space complexity, you're storing n elements. So that means even the space complexity is also O of n. That's all for today's guys. If you have any questions, please do add in the comment section. Like and subscribe for more videos. Thank you.